Check 1, 2. Check 1, 2.
Hello, everyone. Thank you for joining this workshop. This is a hands-on introduction to Hedera, and it's titled Creating Tokens Beyond Just ERCs. I'm Ed Marquez. I lead the developer relations team for Hedera at Hashgraph, and Hashgraph is the organization leading marketing, engineering, and development efforts for the Hedera network. A little bit of context here and background about myself. I'm a mechanical engineer by training. I started focusing on automotive systems and the development of control software, then ended up at an engineering software company doing this methodology called model-based design, creating dynamic system models for complex systems like airplanes, cars, robots, factories, and then developing control software and deploying that on embedded systems to control those complex systems and dynamic systems. And then as I was doing that, I found my passion for Web3. And so I was doing a lot of that on the sidelines in my free time. And it was one of those fortunate instances where the side hobby became the main job. And so I've been part of the Hedera ecosystem formally for 3 years now. And then I've been playing with the SDKs and following from the sidelines for 4.5 years, just about. And in terms of professional interests, blockchain and the overlap of blockchain with other technologies is also something I find very interesting, specifically the intersection with AI, where I see a lot of promise, and I've developed a few plugins and fun utilities here and there. So we only have 20 minutes, and I want this to be hands-on, so I want to go through these slides fairly quickly. And my goal today is to let you know what is Hedera, why build on it, and then how you can get started doing that. So starting with what is Hedera, Hedera is a open source EVM compatible layer 1 network. I'll leave it there. So that's pretty a set of familiar concepts for this audience. And so when you think about what makes Hedera different, I like to think of it in two buckets. One bucket is technology, the other one is governance. So when we think about technology, Hedera has a next generation consensus algorithm that makes it truly scalable, it makes it fast, and makes it very secure. And so I mentioned in the previous slide that Hedera is EVM compatible, and it uses the Hyperledger Besu EVM client as that execution layer for smart contracts. Now, a key differentiator there, it's not only it has performant, fast, cheap, scalable smart contracts, it also has things beyond the EVM, beyond smart contracts. So we have other services that I'll tell you about for tokenizing, for creating timestamps and records, and you can access those services via SDKs in languages like Java, JavaScript, Go, Swift, C++, and Rust. So whether you're coming from the Web 2 world or the Web 3 world, there is an easy entry path for you with Hedera. And then because of that technology and that next generation consensus algorithm, there are other benefits like consensus without leader nodes and also fair ordering. So there's no window for MEV on Hedera. And some people say, oh, MEV is a feature, but it's a feature until it happens to you. And so here you have fair ordering, which is important for various use cases. When we think about governance, it is a global council of organizations doing the governance decisions, driving the operations, and also building use cases on the network, where we have names like Google, IBM, Ubisoft, LG, and many more. But it's not only for enterprises. There's also a lot of Web3 projects and a small community of Web3 ecosystems being built on Hedera. The other differentiator is sustainability. So is the greenest energy or greenest network in terms of energy consumption in the market. And this is a study done by UCL or University College London that shows the energy consumption per transaction of Hedera. And what you can see here is that with the same energy that it takes to do one Visa transaction, you can do about 1,000 Hedera transactions. So really a massive improvement in the order of magnitude that represents. Now, when we think about why build on Hedera, so I mentioned a few things about technology, governance, but there's also a very active community of projects, startups, and founders. And we're also seeing a lot of active developers joining us in global events, hackathons, meetups, being active on the network. We have over 100 applications deployed on mainnet, And to date, we've processed over 70 billion transactions on mainnets. And so that is by far the highest number that I know of any public networks in terms of transactions. And then we've also seen very healthy growth in terms of accounts in total, and also year to date with millions of accounts just being created this year. Another reason is because we have great hackathons, great incentives for you to get familiar with the network and start building things so you can ultimately deploy on mainnet and serve customers. So here we have at ETH San Francisco, we have $10,000 worth of bounties, with bounties for EVM starters, for people just getting started with our native services, and then for more advanced developers where they can build something compelling and walk away with $4,000. So happy to tell you more about those in our booth. And then we also have a big hackathon coming up in about a month. So it opens on November 11th. You can register now. And that one has a total prize pool of $300,000 for those winning projects. So you can learn about that one at hedera.com/hackathon. So let's start building on Hedera. And what we're going to do is we're going to review the services real quick. So the services that I mentioned before, we have smart contracts, which you can see all the way to the right. We have a tokenization service that allows you to create tokens even without Solidity, just using Java, JavaScript, Go, and those other languages. You can create fungible and non-fungible tokens, which is very attractive for those folks coming from Web 2 world. And we also have a consensus service for creating decentralized records, logs. And so you can think of this as a decentralized messaging bus that allows you to have topics and also messages within those topics. And this is the part of the tech stack that is governed by the Hedera Council. And then on top of that foundation is where developers like yourselves build compelling use cases and applications that serve end users. So with all of that context in mind, let's jump in and open up this repository to choose your own adventure on how to create a token on Hedera. So here, I'll leave this URL just for one more second, or if you want to copy the tiny URL, feel free to go ahead and do that. All right, so now, all you need for this workshop to follow along is a browser and a GitHub account. Hopefully most of us already have a GitHub account. And so what we'll do here, if you go to that repo linked in the slides, is you can open it on Gitpod, which will automate any setup that we have to do. And so now that we're here, what you're going to see is that this is going to open 3 different terminals. So these first 2 are just running processes in the background, and then this is the main one that we're going to use to follow along in our tutorial. So what we're going to do is we're going to create or deploy an ERC token on Hedera, and then we're going to deploy a native token on Hedera just to show you those 2 paths that you have to tokenize on this network. So we'll start by generating a seed phrase. This is going to be a BIP39 seed phrase. And we're just going to do that with the default values. So we can just hit enter here. Next, we're going to, let me zoom in a little more. From that seed phrase, we're going to generate accounts, Hedera accounts. And so the default value will be 3. We'll proceed with that. And then we're also going to instantiate a JSON RPC URL endpoint to be able to submit transactions to our network. If you're going through a JSON RPC, that means you're probably working on smart contracts. And then those other native services like the token service, the consensus service, those can be accessed directly via the SDKs. In this case, we'll proceed with this JSON RPC URL value. And next, we want to enter a private key or generate a private key. In this case, we'll also generate one at random by using the default value. Just hit enter there. And now what we have to do is we want to fund this account. So we're going to fund this account by going to the Hedera faucet. So if we do faucet.portal.hedera or portal.hedera.com/faucet, we'll just give it a second here. Now we can enter our EVM address And just like that, we can receive 100 HBAR to start our development and our testing. So there you see that from that EVM address, we were able to create and fund an account. And so now that that account is funded, we can proceed here. And what you'll see is that it's also creating a few additional accounts. So those values that you see in the terminal there, they're now going to be written to our .env value if we say yes, so that we have those variables on disk, right? And now we can start working with all these things. And what you see here is that our JSON RPC is actually instantiated, it's live, and we can probably start deploying our ERC token or ERC contract on Hedera. So what we're going to do is we're going to use the files in this folder, so token HSCS, that stands for Hedera Smart Contract Service. So we'll just do a good old CD. And there you see we have a few files. We can show them here as well. But what you have is a script that we will use to walk through the deployment and interactions step by step. So we'll do /script. And so that's going to walk us through all the steps that we need to run through. So here we can see the lines of code that will be running up to a certain point once we hit enter. And the first thing that we're going to do is we're going to check the Solidity that we're going to deploy. The Solidity contract that we're deploying in this case is a very basic implementation of an ERC20 token. So just the bare minimum that you need to be able to deploy that. So let's go ahead and run that. Next, we need to load up the EVM bytecode and also the ABI of our contract. So there's the code that points you to us doing that. In this case, we haven't done the compilation, so it's going to error out, which you'll see here. That's expected. And so obviously what we need to do is now compile that smart contract into bytecode and also generate the ABI so that we have the summary of the different functions that we have in that Solidity file. So we're going to do that with npm run. And there you see the different options that we have. So the one that we want is this compile smart contracts, because that's going to basically execute a source.cjs compilation that gives us the ABI and the binary for the MyToken contract. So let's go npm run compile smart contract. There we go. Now you see that we have a bunch of artifacts here, binaries and interfaces. And so now we can come back to our script and try to rerun that once more. So yeah, we're checking. Let's proceed. Let's load. And you see that we were able to get the constructor, the ABI string, and here's the important piece, the different functions that we'll have. In this case, the function that we're going to use later on is going to be this transfer function in our smart contract. All right, so now let's check that our JSON RPC is live. We're going to check that with two endpoints here, so get block number and get balance. So we're just calling that, and indeed it is live. So now we can submit our EVM transaction to deploy the bytecode of our contract. So we're going to do that right here. We're using the deploy contract. In fact, I forgot to mention that in this file, we're using VM for the deployment and the interactions with the contract. So we use this deploy contract. Here we're passing the ABI, the bytecode, and some arguments for the constructor, which is just the token symbol and the token name that are being passed right here. So let's go ahead and proceed with that deployment. And then this transaction typically is one of the heftier ones on Hedera. It's probably going to take a little bit more than 3 seconds. That's typically the time to finality that we're working with right now. And once this completes, you're going to see the different links for the successful deployment of the contract. So we can go to Hashcan, which is a transaction, or the Network Explorer. We can see the details for the deployment transaction. There we see it's a contract create, Ethereum transaction type, and a few more details. And then if we come back here, we can also look at the URL for the contract that just was deployed. So instead of a transaction, we're looking at a network entity. So here's the contract, the details. And right now we see all the bytecode and all the assembly bytecode as well, and a few more sets of information like events, but it's not readable. It's not human readable. So the next step that we want to do is that we want to verify that smart contract so that we can have more visibility into the source code, the ABI, and the events that are part of that smart contract. And so I already ran that here, but what you'll see is that Hashcan, the Network Explorer, has an instance of Sourceify that allows us to do that smart contract verification. So now if we go back to our contract and we refresh here, you can see that the contract has been verified programmatically with a full match. And so now we have a few more tabs, not just the bytecode. We have the actual source code and the ABI. And one thing that I didn't mention is in the verification process, what was passed is the source code, right, the Solidity code, and also the metadata that was an output from the compilation process. So that verification just makes this Explorer more usable, and then you can even interact with functions in your contract right there. And so now we're going to submit a transaction to basically write a value and change the state of that smart contract. And so what we're going to do is a transfer. So we're using this object, or the client object, write contract. We pass the deployment address that we want to call, the ABI, the function that we're going to use, and then the parameters for that function. So the receiver and also the amount of tokens that we're sending. So let's proceed with that. There it is. So the transaction has been successful. We see the status. We see the URL also on Hashcan over here. And we can see information here about this specific transaction. So the input, which was the receiver, the amount of tokens that we transferred, and the output, which is true, which indicates the transaction went through. And there's more details about the call trace, the contract state, the events, and so on. All right, so now that we've submitted a transaction, we're going to submit a query. So we're going to read from that smart contract, right? So this is not really a transaction. It's more of a read query since it doesn't really affect the state. So we use read contract for that. We point it to our deployed address. We provide the ABI, the function name, which is balance off. And then we're going to do the address of the account that we want to query the balance for. So we proceed with that. And then we see it right there that it's 100 token units. So the other part that I wanted to show you, so again, we just covered deployment, interactions with, and verification of a smart contract. That was an ERC20. The other part that I would like to show, which I don't think we're going to get through this one because of time, is creating a token directly without even deploying a smart contract. And this is what we call a native entity that lives on Hedera because of that smart contract, or sorry, because of that Hedera token service that I mentioned before. So you see, it's just an import from the SDK package. And then the deployment happens very easily using this token create transaction, setting the properties for the token. And then we walk through the process of associating an account with that token and then transferring that token. But this is code that you can all inspect, that you can try out very easily. And then hopefully it will be helpful for the hackathon portion of this event. So I'll stop there and then see if there are any questions, or if not, we can close and move on. Fantastic. Thank you all very much for tuning in and for joining live. Enjoy the event.
Hi everyone, I am Fabri from the company Ephemera. Ephemera is known as the parent company now of XMTP, but not only XMTP. We also have the app, it's called Converse, which was released very recently. We acquired Converse like in March and we made it open source. So now we are building like the whole messaging stack in the open, soon to be decentralized. So we started with the protocol. Now we are moving into the app, just a way for users to interface with the protocol. And for context, XMPP is an encrypted end-to-end messaging protocol between wallet addresses, these addresses being EVM for now. Everything is off-chain, so messages are stored off-chain, and we are running 5 nodes right now, and eventually the nodes are going to be decentralized and run by community node operators. But today we are going to be talking about MessageKit. MessageKit is the third piece of the puzzle of the messaging open platform. So MessageKit is meant to ride the way of AI agents, bots, automating accounts. So you can think of MessageKit as a small SDK for building apps that you can, these apps could be bots or agents that can be used through messaging apps that work with XMTP like Coinbase Wallet or Commerce. So we are as XMTP protocol, we already have 2 million activated identities on the EVM network. So it's probable that if you have a friend that have a ENS domain, it's probably that you can send a message to him and he's going to receive it, even in Commerce or Coinbase Wallet. Now talking about Converse, as I said, it's on the App Store. It was released recently. If you want to download it now from the App Store, this is a QR code. This is going to allow not only to chat between users, but it's also available for creating group chats and messaging bots and agents that like we are going to test right now. Okay, let's go into one of the demos of MessageKit. If you go to the MessageKit docs, you will find a very simple CLI command. So if I run this command, it's going to prompt me 3 examples. These 3 examples are documented here as well. We have one that is a GM bot. It's going to only reply GM. Then there is a one-to-one that shows me options and the user has to select those options. And then there is a group chat bot that you can tag inside the group chat and can perform actions with the context of having more users interacting inside the conversation. So in this case, let's say I want to create a GM bot, GM test, and that's it. I have already one created with my private key, so I'm going to open it now. And this is the structure of a simple bot. Again, this bot is going to use one identity, which is a EVM address. So I'm sending the private key as a parameter, and that's the only thing that this bot needs. Once you install the packages and run the bot in development, this is going to start what we call an XMTP client. This client now has the inbox ID, which is like the unique identity inside the messaging protocol, XMTP, the account address associated with this identity. Each identity could manage multiple addresses, and the installation ID, because everything is encrypted end-to-end. Messages are only decrypted on device, so they are not available remotely or in any way, and everything is encrypted end-to-end. So let's say we have this bot. Now on the right, I'm handling Converse Mac client. We have a Mac client too. This is also going to work, for example, with Coinbase Wallet or any inbox that uses XMTP in the background. So if I want to send an address to this bot, again, this box will also work for ENS domains. This is going to open up a chat, and I can say hi. And this is a very simple GM example. The bot is replying. This is all the code that you need for creating a bot on top of the XMTP protocol using MessageKit. Now let's go into one more, a little more complex. So this is a one-on-one example. Again, the code is still, although it's more complex, it's still very simple. I use Cursor for basically building all this stuff. So it's very easy to create like a conversational dynamic. So let's try this one. Bondev also has the same private key from my wallet address, so I'm going to keep using this one on the right. Hi. So this bot now triggers options and is going to be listening for which option do I select. So I want info, here's the info, and I want to subscribe, and I just subscribe. And what it's doing, this bot is subscribing me actually to a Redis database. This Redis database was one that I picked, but you can think of an example like this for managing subscriptions. And then of course, once you have the user, you can send notifications through XMTP, and they will receive it in their ENS addresses or wallet addresses in Coinbase Wallet, in Commerce. So yeah, you can think also XMTP for engagement or reaching users through their addresses. Okay, this is still simple stuff. Now let's go. So here we start, and this is the cron. This is an example cron that will send one message a day for the subscribers. And if I want to unsubscribe, this is going to remove my address from the database. And the Redis middleware, also very simple. Everything is documented here in the one-to-one example. Again, the structure of the message kit bots, it's an index file which handles all the logic, and then we'll have like different handlers or middleware code also ready to copy paste. So now let's get into a group example. These all come from the CLI starter, so I'm just using pre-created ones. And now we are going to introduce what is called commands, and through commands we are also going to learn what's intent at least in the context of MessageKit. So let's trigger this group bot. This group bot is going to be handling different interpretations of what the users are doing. So in this case, I'm going to create a new group. I'm going to send this address to the group. Sorry, new group address. Add this address. In this case, I'm going to add myself. This is my mobile identity. Next, I can set the name of the group. Okay, we have now created a group. This is using MLS for encryption, so everything is encrypted end to end. One thing that you will encounter today is that if you join a group after it was created, you're not going to be able to see messages before you joined because there is no message history, because everything needs to be encrypted on device. We are working on that, but that's something that you may encounter as you start using Commerce. Okay, so if I say hi, nothing will happen in this case, because if it's a group, you need to prompt the bot explicitly. We don't want bots to be listening to every message in every group chat. So for that, you will need to create what we call the command file. So the command file is going to declare explicit commands. So in this example that is also documented here, I have like 6 use cases. So how to use an agent that is AI powered, how to do tipping, how to trigger a game, how to trigger frames that trigger transactions, doing split payments, and also like managing a loyalty program inside the group chat. So let's see. Each command, each bot will be declared here. Each bot has its own commands, and these commands also have predefined parameters. So the message kit is going to be handling the parsing of the commands. So it needs to know if it's a username, a string, a number, and so on. So let's start with simple stuff. So if I want to say, I'm also going to use Bo and Alex. These are like test users for the demo. They are not in a group, but I want to say tip Bo 20. So what's happening here now, this message is logged because tip is in one of the triggers. The trigger is explicit, so now the message is logged. And what happened here, the logic from tipping, I'll see it in one of the handlers. So basically here it says, if the text starts with tip, do something. I'm not transferring real tokens here, but this sent me a DM. So from a group chat, this has sent me a one-on-one message notifying me that I just sent 20 tokens in total. Or even I can say tip Bo and Alex 100. This is going to be 100 each, so I send 200 tokens. Again, this is just an example, but showcasing commands and showcasing that the bot can also message you, send you a DM. Now, let's see what else we can do. We have one command that is declared as an agent. So this will trigger basically GPT. Now, agent, tell a joke. Now the agent is going to be replying to the group. Why the Web3 developer always carry a pencil and a paper? Because they never wanted to lose their right access. So that is supposedly a really funny joke from the demo. So now you can start to think about infinite use cases, right? How you put AI inside the group messaging and what other things can happen.
Question?
Yes.
Or after?
Yeah, sure.
Does the AI agent, can you give it like context of the entire conversation? Like,
We are thinking about that. So for now, we have what we call guidelines for building responsible bots. So because you may be in a group, I may add an agent to the group. We may be friends, but maybe you don't know even the developer of the bot, or if the bot is like good quality or has bugs, or what it's doing with the information. So we are not encouraging the bots to handle every message in the context, in the conversation. So that's why you need to explicitly tell agents to tell a joke. If I say tell a joke, the message is not going to be filtered through MessageKit. Nothing happens. So yeah, this.
but if I prompt it explicitly, can I give it access to all of the conversation I had before? Can I say, look at everything we talked about? And
Yeah.
Okay, so
Again, you could do that at the protocol level, but yeah, that's a tricky question. Thank you. I mean, you could, but we are not encouraging it because it will read messages from all the users, right? In a one-on-one, yeah, you could just download the whole message history and do whatever you want. You can do as well as in a group, but yeah, personally, I've been trying to think about when would you want to use all the messages, and I haven't come out with any good ideas.
some good ideas.
You have good ideas? Okay, let's chat. Let's chat. Okay, what else? Games. So if you are familiar with Farcaster frames, Converse also is compatible with them. And maybe you heard about the game Wordle. So, but first, let's see. I want to trigger the help command because games has the game command handles a help that is going to suggest me which games can I play. So Wordle and slot. Okay, I want to play slot. Okay, there it is. Yeah, just a funny example of playing slots. Let's see if I'm lucky. No. Okay, and then the Wordle game, which I would love to play it, but it may take us some time. Let's try it really quick. I always do these 2-word starters. Any suggestions? In the meantime, someone has questions? Yes.
Yeah, can you call other contracts from the bot? And if so, then how do you handle the gas fees? Like, is it one bot from like Metamask or something?
Yeah, so inside the bot, this is a node backend. These are deployed. Let's see how they are deployed. This is using Rivewell. As you can see, I have a couple of bots. And let's say So yeah, it's just deploying from the GitHub repo. What I was trying to say is that from this backend, if you have the private keys of a wallet, you can do anything that you want, right?
Okay.
There is no restriction, at least from the message kit side, as long as you have the wallet. And we are soon going to be integrating smart accounts into Converse. So then you may be, it's going to be possible to perform actions for the user. But right now you will need to perform actions from a wallet that you have the access or private key.
Okay. So you have to add that private key and then they can play a game, online game.
Yeah, you can fetch smart contract info, do whatever, transfer funds, and then the bot to communicate status or whatever you want. Okay, let's. Okay, that was yeah. We saw a couple of examples. So let's return to the presentation and.
Do I need to deploy it on the railway, or I could deploy it on my own server?
You can deploy it anywhere. Yeah, I'm using Railway because it's super fast, but yeah, and I also can create like a Redis database very easily. Yeah, but any backend will work. So by building MessageKit and building with AI, we are trying to figure out how we can, give structure to all of these, how agents are operating now. And as maybe you've seen, OpenAI is the roadmap to AGI. It was first conversational bots, second is reasoning, and the third one is agents. So this is something that is going to get more interesting really, really soon. So there are 3 stages of intent. The first one is explicit intent, so /commands, as we've seen. You can declare them, the user can use them. Maybe you have background in Discord or Telegram. I do. I always like to play around with commands. And as we've seen, you declare the commands very explicitly. And then you can handle, so MessageKit is going to parse the parameters, and here you get amount, token from, and token to, ready to use. Now, natural language. Now let's say we want to swap one UCC to ETH, please. Now the prompt is not super strict, so this is not like a literal command, right? The AI needs to parse this command. So what's happening here? I'm using simple prompts as example. The prompt is, hey, if you receive this string prompt that is requesting a swap, you need to parse it as a strict command, and this strict command now is useful for MessageKit, and this is going to be triggered like in a recursive way. So MessageKit is going to be triggering the command to itself. Now let's take a look at that. This is swapbot. Okay, let's chat with swapbot. So nothing is going to happen here. Now if I say swap 1 ETH to USDC, please. And now this is triggering a frame, and the frame already knows that is 1 ETH, 1 USDC. And these are all parameters sent via get parameters. So the URL, you're going to find that these parameters are embedded into the URL. And the cool thing about this is that, so on the left I have the way to parse a command. But how do we parse the natural prompt? So this small handler is going to use the system prompt, and it's going to return me a / command. And as you can see in this log, the intent was, this is what the bot returned, an intent message that starts with a /. And then if I just run intent to MessageKit, now goes through itself, goes through the swap handler, parses the commands, and returns the goal that was the URL of the frame. So this is the second level intent. Any questions so far?
Is it possible to generate a private key for a XMTP bot, like on initialization?
Yeah, sure. Yeah.
How do you do that? Using a seed? Or
Traditional hex address. Yeah.
yeah, so you pass the private key as in the env variable, right?
Yeah. In this example, they are using it. I'm only using one from the M file, but you could send the key here as a parameter, and I could send private key and send a custom private key, like my key one, and then I can create many of these, and each one to have its own private key.
But it will be deterministic, right? Like if I pass a seed, I'll be able to get the private key, right? I don't want it to be deterministic. Right?
To get a private key from a seed, I haven't done that like in code. I guess, yeah, that should be straightforward. And then the thing that the seed generates, you will need still to get the private key for sending it here. Okay, so that was second stage. The reply starts with the slash command, then triggers intent. And the third one is reasoning. So this agent is going to have more things to play with. I'm going to run ENS agent here. And in this example, the bot knows 3 commands. So check is going to check for the domain. Register if we want them to, if the bot wants to register ENS domain, and information about the domain. And again, a simple prompt that is going to interpret whatever the user says. And this prompt is different because it's going to allow me to, this prompt can reply more than one message. So it could reply, please let me check, and then actually check it, and then send you even the response of that. So let's see how that could work. Okay. If you want to know how this continues, yeah, just in the good stuff, no worries. Okay. That was the last level of intent. This is using also short-term memory that makes the bot work better. And yeah, that was MessageKit, powered by Ephemera, XMDP, and Converse. So happy to see you at the booth if you have any questions. And yeah, thank you.
And out there on the web, I'm David. That's Wyatt. And in the next 20 minutes, we're going to do a brief introduction to Lit Protocol, some of the prizes that are available here at ETHGlobal San Francisco, and how to get started with the SDK. So first, just to do a little bit of context setting. Basically, one way to think about the problem that is solved with distributed and programmable keys, which is fundamentally what Lit offers, is addressing the issue of fragmentation. We live in a fragmented world. Everybody knows this, even if they're not technologists. And so the thing that unifies all systems, networks, platforms, devices, is that they all use secrets for authentication. And so the big insight, if you take away one thing here, is that you can make applications, agents, and protocols that interoperate across multiple blockchains, multiple networks, multiple services by using Lit, which is a system for managing secrets that are distributed and then creating applications that dictate how those secrets are used, like signing a transaction, decrypting some data, hitting some endpoint. And so we've had the mainnet beta up since February of this year. The network has done 20 million requests to date, just about. And now I'll tell you a little bit about the security and then pass it off, then a little bit about the prizes, and then pass it off to Wyatt into the getting started, and we should have plenty of time for Q&A. So looking from left to right here, this is kind of in order of scale. We'll tell you very briefly about what these nodes consist of that enable this notion of creating a programmable secret. You can see there's 4 components. There's sealed hardware, which is encrypted VM, a type of trusted execution environment. And within that sealed hardware component, there's a networking module, a threshold key share, and an execution module. And so then moving to the right, this is functionally what's live today. These green circles indicate the threshold key. So the key share that is managed by each of these nodes is a different part of an underlying shared secret, and through the execution module can write actions, and we'll get into that in a minute, that dictate how this distributed secret management system will sign and decrypt things. And then a little bit to the right is kind of where we're headed in terms of how this continues to scale. One of these networks today can handle about 400 to 600 concurrent requests a second, which is pretty awesome, but certainly in order to have this network work at an internet scale, there's still some scalability adventures ahead. And so the execution method is called a lit action. That's the JavaScript code that runs in this execution environment. And so you can basically say, hey, lit nodes, I want to decrypt some data, or I want to broadcast the transaction. And this is how this has worked for some time. And then recently, within the past several months, we've added a new feature, which is enabling one of the nodes to collect these authorizations from all of these shares so that data can be decrypted in a single node and then used in whatever the next step in the program is, or can collect the authorizations to generate a signature and broadcast that to a blockchain. Being able to decrypt data, broadcast signatures to chain without a human in the loop, really for the purpose of some pretty sophisticated automation. And then like Fox uses this, for example, for doing their access control on their licensing network that's called Verify. We've seen some life insurance teams use Lit as a way to take private user data, like personal identifiable information in the context of life insurance, like pre-existing conditions, is somebody a smoker, things like that, and run a model against that inside of Lit, inside of this private environment. And then the output is something like a risk score. And then so an insurance provider can underwrite Alice based on her risk score without knowing personal information about Alice. And then finally, this also applies to interconnecting blockchains. And so what you're seeing in a short demo, this is an application called Genius, going from USDC on Base to a meme coin on Solana. And what we'll see in a second is I hit the swap button. This is a pre-recorded video, but this is actual transaction. It's now simulating the transaction. And then upon hitting submit order, you could see that that clears in less than 2 seconds. And that is made possible because for this system, for example, the way the architecture works is there's actually 4 programmable keys in play. There's the user wallet on Base, which is holding that USDC. There's the protocol or orchestrator wallet from Genius on Base. There's a protocol and orchestrator wallet on Solana and a user wallet on Solana. So that simulation happens ahead of time. And then upon hitting the swap button, the funds go from the user wallet to the orchestrator wallet on Base. And at the same time, the orchestrator wallet on Solana is buying that meme coin on a local Solana DEX and sending it to the user wallet. And because all that key material is using a lit key, a programmable key pair, the user can't rug, right? Those resources are locked. That is essentially going to be completed as an atomic transaction. And they do some other sophisticated things like log in with Apple and Google and direct funding through banks and Coinbase for the onboarding. And so this weekend, there are 3 core prizes. These can also be combined. So computing over private data. This means like decrypting some information inside of Lit and using it for some purpose. You could decrypt an API key for creating a marketplace for inference data, so agents can use it for microtransactions. It's just a concept where we talked about that insurance model earlier. Also, the programmable signing, which is essentially broadcasting a transaction directly from Lit. You could also use this for things like verifiable credentials, use this to call things like sign protocol. And then this is something that we've never done before, but having a prize for a programmable Bitcoin application. So the way that this works, and we can go into some of the specific docs, and it's also listed on the prize page, but you can think about using Lit to program Bitcoin because you can program an account, externally owned account in EOA, and because you, with Lit, can create an immutable but upgradable program where the output is a signature, you can essentially write a DeFi primitive, for example, that is mutating state on Bitcoin based on some other state, perhaps state on Ethereum or an L2 or Solana or in Web2, whatever it might be. And then, yeah, if you take your best shot at this, but somebody else gets selected, then there's some runner-up prizes as well. And so with that, I will, 1, see if there's any immediate questions, and then 2, pass it along to Wyatt, who will go into all of the getting started details. Awesome. Oops. Let's bring that back up. Alrighty.
Yeah. Hi, everybody. I'm on the DevRel team for Lit, so I'm here to support y'all while you're building on the hackathon and afterwards going forward. On our documentation, the website is just litprotocol.com, and then we have a link to our docs. Under the Get It Started section, we have a Making Your First Request. This will guide you through all the prerequisites, including getting test tokens for our network, instantiating a client with our SDK to be able to connect to the network and make your requests. Generating session signatures is how you authenticate with the Lit network, so we can identify who you are, who you have access to, what PKPs and other assets that you have access to. And then, of course, installing the SDK. And these 2 are really good to learn. Making your first decryption request, it just walks you through all the steps, gives you the code snippets that you can just copy paste and get up and running with that. Then secondly, making your first signing request using a PKP. This is like the decentralized key pair, where no one actually owns the underlying private key. Aside from that, for our Bitcoin example, if you go under guides, user wallets, and then PKPs, under our advanced topics, we have signing with Bitcoin transactions, and this will walk you through signal signatures, multi-sigs, all of the Bitcoin stuff to get you started with that. We have additional documentation covering various topics. Of course, feel free to reach out to us on our Discord, the ETHGlobal one, or the Lit Protocol Discord, or stop by our booth, and we'll be happy to help you with any debugging or answering any questions for integration. And if there's any questions.
So I was looking at one of the examples for encrypting your API key. What would be the point of that?
The question, to repeat it back, was what would be the point of encrypting an API key? So a very basic way to think about it would be to resell it. So let's say you have a smart contract that needs access to some data. There's all kinds of systems that do this, Oracle's, Chainlink, etc. But let's say that's premium, exclusive, private priced data that isn't just necessarily freely available. You have access to an API, maybe you pay for that data. You now want to take that API key because you've set up this whole Web2 construct, and you want to sell it on chain for 50 cents per request. When somebody pays on chain and says, oh, I'm paying for 1 request, you're not generating a new API key for that person because it's a smart contract. It doesn't really have a method to call an API, but inside of Lit, it can decrypt that key and use it to pull that one request with whatever specifications came with the request, the order functionally, to pull that data from that API. Is that helpful in terms of like essentially commercializing it on chain is a short way to put it. And then, yeah, the example I mentioned earlier is something that I personally am really excited about, which is there's, you know, a bunch of like API marketplaces that are out there. Rapid API is the biggest one. To me, it feels just like a pretty significant and exciting opportunity for a team to tackle that truly in like a Web3 context where make all APIs available through microtransactions where the data providers can either be networks like Chainlink or existing providers of Web2 APIs that can hook up to such a system to then make them commercializable via Web3. Great question. Thank you. Anybody else have any questions? We can cover specific implementation details. If somebody wants to share what they're working on and be brave, that would be cool. No pressure, though. We could deconstruct that. Yeah, we could talk about ideas, implementations, the security of the system. Yeah, absolutely. Great stuff. So the compute method, let me go back to my, the question is around how does compute work with Lit? And so the compute method is what we call a Lit action. And so this execution environment that's running in the secure hardware environment is actually a JS execution environment called Deno. So Deno is just running inside of the Lit node. And so let's say you have a function to determine if a number is prime or not. And you write that up in JavaScript and you say, Lit, hey, here's a number. Is this number prime? That execution will happen here in the TE, and then you could have the signed result delivered with the threshold key. And then one thing that's really cool here is that you can pass that JavaScript directly to the node, but to the node set. But what a lot of teams do, and the system is set up this way, is actually to upload that JavaScript to a specific content ID or CID on IPFS, thus making that function for automating the signing immutable in the same way that once you have that CID address, you can't change the contents that's on there. But then just add another interesting level of detail, there's also teams that want to have the same property of smart contracts for these signing applications. So they will point Lit at a specific smart contract. The smart contract will contain the CID, which is the JavaScript for the system to run. And then if somebody wants to upgrade their system, they do a function call to the smart contract and they remove CID A, add CID B. And so the next time the network is called and says, oh, what is the JavaScript that I need to run here for is this number prime or whatever the use case is, it'll go to that new CID and grab that new updated JavaScript for that immutable but also upgradable property. Excellent question.
Are there any source limits for the decentralized compute, like API call, request?
Yeah, why? Do you have the limits top of mind?
Yeah, it's like a 30-second execution runtime.
Here, yeah.
Sorry, the question was any restrictions on the execution environment. I believe, see if I can find that real quick. If not, it's okay. Yeah, it's like 30-second execution time. I believe 256 megabytes is like the total file size that will run. I think that's correct.
If you have a longer running compute job,
Like for AI.
yeah, if you have a longer running compute job, like that's basically the direction we're kind of heading in. So I'd love to kind of hear about those use cases. You know, I think right now these TEs that are running, like they're just encrypted VMs. Where we would want to go in the future is having GPUs on the Lit nodes and things like that. So we're still in this mainnet beta phase, but if you have like a use case that requires a longer running job and you're running into those limits, that's a great reason for us to talk to us. Like that's very much the direction we're heading in, is supporting longer running jobs. good stuff.
Yeah, I have a question about this. So, as far as I understand, IPFS is not like encrypted, right? The data we uploaded.
Hmm.
So, can we somehow use lit to, like, could you explain the workflow how we would introduce lit?
Absolutely.
Like a very simple application, it's React. We're trying to upload data to IPFS, but we want to encrypt it.
Yeah, so we can look at an example. So like Lens protocol has the notion of gated content. And so this is, they're using IPFS, and basically the way that this works, in the Vox example I mentioned earlier, works in the same way, but we can talk about it in the context of Lens, where Alice has a song. Alice wants to upload this as gated content into Lens, for example. That content is encrypted to the lit public key. Now Alex has the ciphertext, the encrypted data. Alice then stores that ciphertext on IPFS and sets a rule around who can decrypt it. And so let's say the rule, for the sake of example, is you must own one Alice token in order to decrypt this data. Bob is a fan. Bob has an Alice token. Bob shows up later on, and when he's going to decrypt the data, Bob basically signs a message and makes a one-to-many connection to all of these nodes and says, I'm Bob, here's my Alice token that I can prove with my signature. Each of the nodes then checks to see, does Bob meet the rules for decryption? And then each of the nodes, now in a many-to-one operation, send those authorizations back to Bob, who now has a signature client side and the ciphertext, and then can decrypt that ciphertext client side. Awesome. Yeah. And then so just to kind of jump back to one other detail, that's basically like in that example, this purple square is Bob. And then what some of the prizes are focused on is this notion of decrypting within lit. That's where Bob is replaced by a lit node, where that data actually is decrypted inside of lit and then used as input for the next step in the program. But both of these methods are available. Just the hackathon is a little more focused on this newer use case of decrypting in the action. Yeah.
In terms of gating content, can you go over some of the examples of, obviously you could be a holder of an NFT, but I think there was also some notion of maybe using OAuth and some other.
That's a great question. So there are like basic examples, hold an NFT, hold an NFT in a collection, things like that. But you can also use any contract on any chain. And then these things can be combined with Boolean logic. So you can do and or operators amongst these. Time lock is also available based on block count. And then you can also use the networking module, the data input output module inside of lit to then fetch external data and use that as the access control. And this could all be combined as well with the Boolean logic. Yeah, so like just looping in some other kind of folks that are here. I know the team at Story Protocol, I believe they have a repo where they have already connected lit to the Story contracts using their custom contracts. So it's like you purchase the license on Story, you can decrypt the content type of thing. And that uses this methodology of the custom contracts. Does that answer the question?
Yeah, I mean, I guess I'm specifically curious about sort of some lit to kind of authorization.
Yeah, that would be through this, what we call a lit action condition, where you would do that verification here in the JavaScript. Maybe you have to reach out to Google's server to confirm the validity of that OAuth token, and then do the access grant. Yeah. Come by the booth later. I think we could dig through and see what would the most relevant example would be. Yeah. Awesome. Anybody have any thoughts? We have the booth. It's kind of in like when you came in the entrance, there's a green wall on your left. We're just on the other side of that green wall. If you're a fan of wordplay, we have some matches. You're lit. Yeah, great. Love that. So yeah, you can come grab one of those right now too. I know we're about to wrap up. It looks like. But yeah, we'll be around. We'll just saunter back over to the booth if you want to pick up any aspects of this conversation, and we'll be here all weekend. Thank you all so much.
Okay, looks like we are ready to start. I hope you enjoyed the little break. In this workshop, we're gonna look at oracles. We're gonna have a small crash course on oracles with Chronicle protocol. Before that, I'm curious who here in the room has a team for the hackathon and who knows what they're gonna build? Raise your hand. Okay, a few of you. For those that are still exploring, come by the Chronicle booth. I'm gonna do my best to pair you with other people looking to join a team and also help you iterate to find something to build this weekend. Now, I want to, before we jump into the technical part, I want to give you a first overview on Web3 oracles for any of those that might be new to the Web3 space or just for those of you that need a refresher. The way I like to explain Web3 oracles is by making this analogy with a mobile phone. So your mobile phone is powerful because it allows you to interact with different apps. In order to do that, you need an exchange of sending and receiving information. Now, when you're boarding on a plane and you put your phone on airplane mode, you lose all that. All of a sudden, you lose a lot of functionalities from your mobile phone. Not to say that it becomes pretty much worthless. Now, having this analogy in the blockchain space, you can think about the blockchain, the chain, as your mobile phone. You can think of it as a sandbox. So beyond that sandbox, it doesn't know anything about what's happening out there. It doesn't have any sort of information beyond that sandbox. Here is where Web3 oracles come into place because they enable information which is outside the chain to have it on chain to power different sort of the apps. And this is quite powerful. A few words about myself. My name is Bianca Buza. I'm lead DevRel at Chronicle. At Chronicle, we offer oracles, decentralized verifiable oracles. In terms of the agenda, we looked at the Chronicle problem, the Oracle problem, sorry, and why it's important to have oracles in order to bring data on chain to power different sort of applications. We're gonna look now why Chronicle specifically when it comes to different Oracle providers. Then we're gonna look at what we have in-house for ETHGlobal San Francisco. We're gonna look at the bounties and what you should do in order to get some of those bounties. And last bit, how you can be successful building with Chronicles. I want to make sure you have all the tools and all the information you need in order to be successful this weekend. Now, a few words about Chronicle. Chronicle has been around since 2017 in a way or another. It has been powering makers since 2017. And a very interesting fact is that it was the first Oracle on Ethereum. Now, I'm sure some of you are thinking, okay, this is interesting, why I didn't know this? And that's because it used to be part of MakerDAO and powering exclusively MakerDAO until last year in 2023. In 2023, it spun out of Maker. Now it's now under the branding of Protocol, and it's open to the whole Web3 ecosystem. In terms of TVS, or total value secured, it secures over 6 billion of assets, which is great news. Not only that we have an Oracle that has been existing successfully for such a long time, but also it secures a great amount of value. Now, a few words about Scribe. So Scribe, it's an extremely gas-efficient Oracle using aggregated Schnorr signatures. Schnorr signatures have been around for a while, since the 1980s to be precise. However, this is the first time that Schnorr signatures are used in the context of Web3 oracles. And I'm gonna show you in a second why this is so powerful and what sets apart Chronicle from other Oracle providers. So we're gonna look at three properties: decentralization, verifiability, and scalability. The first one is decentralization. Chronicle is powered by a decentralized network of feeds. also called validators. You can see here some of the most prestigious and well-known protocols out there in the Web3 space, such as Gitcoin, MakerDAO, ETHGlobal, Mantle, and many more. What does it mean? It means that the data that you use is signed by these prestigious operators in the space. So they're staking their reputation, basically, to make sure that you have the right data. The next property is verifiability. So with Chronicle, you can have end-to-end verifiable data. And I want to give you a short demo how you can do that on our dashboard. So if you go here at chronicle.org/dashboard, you can find the different oracles. Let's say I don't know, ETHUSD. For ETHUSD, I can see here the different validators that are contributing, and let's say I select EtherScan. I can see the different data sources used by EtherScan. You can see here a combination of on-chain and off-chain data sources. Even more than that, I can go a step further and verify in the browser that the signature hasn't been altered, the signature of the validator. So this is like if I don't modify anything, if I adjust it even slightly, let's say I delete 1 0, I can see that the signature doesn't match anymore. Similarly, I can verify the Schnorr signature. This is the signature of the data that gets pushed on chain. Now, going back to our properties. So we saw the verifiability, end-to-end verifiability. Next, we have scalability. So with optimistic Schnorr signatures, with the aggregation, we are able to offer gas fee reduction by over 60% on L1s and 68% on L2s. The first benefit I'm sure that comes to your mind is like gas cost, obviously, which means like you pay less for your Oracle. But I think even more powerful and more important is the fact that it decouples the Oracle update gas cost from the number of validators, which means that now, because you don't have to worry for the price you're paying, you can actually have additional validators. You can actually achieve true decentralization. This is very powerful, in my opinion. Next, we have the fact that it's blockchain agnostic. So right now, it's live on 10 chains: Ethereum, Arbitrum, Mantle, Polygon, ZK EVM, Gnosis Chain, ZK Sync, Base, Optimist, Scroll, and most recently, Berachain. And we're continuously integrating with additional chains. For the hackathon this week, you are free to use any of these chains. For your projects, either testnet or mainnet, any of those is fine. You can even check the other partners for this hackathon. Some of these are also offering bounties, so you can potentially grab more bounties at the same time. Now, since I mentioned bounties, let me give you an overview of what we have prepared for this weekend in terms of bounties. We have 3 tracks. The first track is best integration of Chronicle protocols oracles. We have 2 prizes here, and we want with this track to give you pretty much flexibility with your project. So whether you're considering to have, for example, dynamic pricing for a game or a reputation system, AI optimization for DAO treasury, you name it. We want to give you full flexibility. The single condition is that you use one of our price feeds, one of our oracles. The next track is the DeFi track. In this track, we're looking for different sort of applications, DeFi applications powered by Chronicle protocols oracles. So you can think here, these are only some examples, but there are many more. Lending protocols, decentralized exchanges, yield farming strategies, prediction markets, stable coins, etc. Now, the last track, and probably my favorite. So, as you might know, with ETHGlobal, there are what I call veterans, people who go to a lot of hackathons, people who have been around maybe in the space for a while, and they're very comfortable and they can build something very quickly. But we also have newbies, and we need to make sure that we are inclusive to everyone and everyone gets a shot to build this weekend. So for those of you that might be a bit new to the space or they want a slightly lighter challenge, this track is for you. This one is the education track. And here we're looking basically for the best technical tutorials for developers integrating with Chronicle oracles. You can, I forgot to mention, you can scan the QR code, and in fact, I invite you to scan the QR code. It will get you to the page for our bounties, to this page right here. So in our docs Chronicle at ETHGlobal San Francisco. And here, pretty much, you're gonna have all the information that you need to hack with Chronicle. So starting from the contracts you can find them either in here in the docs or on the dashboard. I personally prefer on the dashboard. When you toggle this dev mode, it takes you to testnet. You're probably gonna use testnet, I assume. Then you have here a notice about the self-kisser. So Chronicle oracles are read protected by a whitelist, which means that in order to read from the oracles, you'll first need to be whitelisted. Now, the good news is that on testnet networks, you can whitelist yourself. We call that a self-kiss. And here, basically, you have a guide that explains you how you can whitelist yourself. Please make sure when you whitelist yourself, you can see here the self-kisser. It's called the contract that enables the whitelisting process. Please make sure you're on the correct network. You can see that the self-kisser has different addresses based on the network. Also, some other things, other recommendations that I would like you to pay attention when you're building. Make sure that, yes, you grab the contract addresses on the network you intend to build. Make sure if you're using more than one contract, more than one oracle, make sure you whitelist yourself for each of those oracles you intend to use. And let's see if I have one more recommendation. I think there was a third recommendation I had for you. Oh, for the whitelisting, that's a write operation. So you will need funds on that network. So make sure you have some funds in order to whitelist yourself to cover for the gas. That's it in terms of recommendations. Let's see what I have next. Okay, I mentioned this. Maybe I show you a little demo right now on Remix. This is a contract that you can find in our docs. So if you look in our docs at tutorials, then consuming Oracle data, you can see this brief contract for Remix. Let me see, so to zoom in a bit to make sure that you can see this properly. So we have this Oracle reader smart contract. Then we define a Chronicle variable of type iChronicle, and we make sure to point it to the oracle that we want to use. In this case, this address here corresponds to the ETHUSD oracle on Sepolia, as you can see here. But of course, you can pick whatever oracle you want on whatever network you prefer. You have all the addresses in the docs. Then we defined this self-kiss instance of type iSelf-kisser. This we point to the self-kisser address on the network that we intend to use. Again, in this case, it's on Ethereum Sepolia. And then in the constructor, we whitelist for that specific oracle that we just defined in the variable Chronicle. Then we have a simple read function. This one will return the value of the oracle and the age. The age represents the time, the Unix timestamp when the oracle was lastly updated. Was updated last, yes. And this is just like from the interface. I copied the interfaces. So it's quite easy. Maybe I do you the demo. So let's compile this and deploy. Make sure when you deploy that actually you deploy the contract and not the interface, because you won't be able to deploy the interface. We confirm this. And let's wait for a bit. I have already here an instance because I wasn't sure how the Wi-Fi will allow us, but seems that it's working fine today. So let's wait for this fresh instance. Okay, we have it here. So this is our Oracle. This is our read function. And you can see here there is quite a large number. No, Ethereum didn't get up to that number. I wish we were living those days. It's just that Chronicle oracles operate with 18 decimal places. And then you have the age of the oracle, so when it was lastly updated. Other important nuggets, let's say, other resources that I want to show you are under guides. This one is a guide on getting read access to contracts. And here you have, again, the self-kiss addresses, as well as two methods to whitelist yourself. The first one is using the CLI, using Cast, a CLI from the Foundry team. And the second option is using directly EtherScan. So with EtherScan, for example, I can show you quickly here. This is like the self-kisser contract, I believe. Yes. Let's see. This is the self-kisser on Sepolia, and if you go to right contract, you can see here two methods. It's overloaded, and that's because you have either the option to whitelist an EOA, an externally owned account, when you're whitelisting yourself. But in most of the cases, you will want to whitelist another address, the address of a smart contract. So you're going to go ahead and put here the address of the oracle that you want to use. And here, you're going to put the address of the smart contract that will read from that oracle. And after that, to verify, you're going to go to the address of the oracle that you just whitelisted for. And you can see here we have told that you can query. Again, you can verify if an address has been whitelisted, and it's going to return a bool, either yes or no, if it has been whitelisted or no. Or you can even go and find here, which returns an array of addresses, and you can find the address there, but it's easier if you do this query with bool. What else did I prepared to show you? Oh, we also have a Scaffold Oracle Reader. For those of you who are familiar with Scaffold ETH from Guild, you have this integration, so you can get you up and running, and you can focus on the parts of the projects that differentiate it. And then last but not least, our handles. You can also find us the whole week at the Chronicle booth. So in case you have any questions or you need help, please come by and say hi. Any questions? Okay. We have.
If I wanted to get whitelisted in mainnet, what is the process for that?
I'm gonna.
Not for the hackathon, but yeah.
Yes, I'm gonna repeat the questions because this is what I was being told for the recording. So if you want to get whitelisted for mainnet, you need to come talk to us, and we're gonna be able to whitelist you. So the permissionless whitelisting process, it's only for testnet. But that should be enough for the hackathon.
You said there was like the Chronicle Oracle and then the Scribe Oracle. Are those different things?
Scribe is this is how we call our Chronicle oracles. It's our flavored oracle using the signatures that I mentioned earlier.
So there's just one or there's two?
This is how we call it. Yes, you can think of it as one oracle, yes.
Do you guys just have data feeds for like token prices, or do you guys also have data feeds for like real life events like sports and all that? Because I wanted to do something in prediction markets, but like I need oracle data for like sport events. Okay,
so the question was like what sort of data feeds we have. Currently, we have different DeFi data feeds, and also some RWAs, real-world asset data feeds. However, those are also mainly focused on the financial aspect. You're gonna find stuff like T-bills, and yeah, all the fun stuff. Okay, I'm getting signs that we're getting at the end of the presentation. Thank you so much, everyone, and happy building.
chain to abstract them all. Today's agenda, if you go ahead and all you guys in the crowd with your cameras, if you want to scan this will just take you to a link tree. The next couple slides will have the same QR code. So yeah, anytime, just go there. It has a link to these slides and all the resources that you're going to need for the hackathon this week. Cool. So today's agenda, I'm going to go over hackathon bounties, going to do a little bit of an intro to Near, go over chain abstraction, what that means, what it is, also Near and AI, and go over a little bit of hackathon ideas to get you guys started. Then, of course, we're going to end up with dev resources and make sure that you guys are well equipped for success moving forward in your project. So yeah, first off, hackathon bounties that are going on this weekend. We got $10,000 in prizes to give out. 6,000 of it is going to be towards chain abstraction, and 4,000 of it is going to be some way in which you're going to combine Near with artificial intelligence. So yeah, good luck. Hope you guys, submit some awesome projects, and looking forward to seeing them. So what is Near? For those of you that don't know or haven't heard of us, in 2017, it started out as an AI development platform. They wanted to do a bunch of payouts to people helping out with this initiative through Ethereum, and at the time, it was a little bit difficult to build on. So they decided to make a quick pause for 6 months and do a layer 1 blockchain. Yeah, it's been a little bit longer than 6 months to make that a reality. But the idea was, hey, we need to make this easy to use. We want to make it scalable. We want to make it fast, secure, and also eco-friendly, and being proof of stake. So 2020, we spent 2018 and 2019 working on mainnet, and we launched it. We actually, created a proof of stake blockchain, certified carbon neutral with South Pole. It's sharded by design, actually down to every account can be its own shard in like a future scalable roadmap. Right now we're about a second block time, just a little bit over, like 1.3 seconds. We're cheap, 0.01 cent per transaction on average. And yeah, over the last 4 years, we've had 100% uptime, which is pretty awesome. 4 years in counting, we just celebrated our 4-year anniversary this October, and have almost 1 billion transactions that have been processed on the blockchain. Yeah, we've sustained about a 14 million transaction per day spikes with some of the top apps in the ecosystem being on our platform. So, chain abstraction, what is this about? Well, it really starts kind of in the beginning before we started talking about chain abstraction with the account model. And with the account model on Near, there's basically like 2 different types of accounts that you can have. The first one is probably what you guys are all familiar with coming from Ethereum, our implicit accounts. We use a curve of 25519, 64 characters, and that would be like basically your public key would be your account, an implicit account. No need to fund that. This is an example. And we do have named accounts. These are kind of what sets us apart from being like how we baked it into our protocol to begin with. So each account, is more human readable. You can have alice.near, bob.near, josh.near, whatever, you want. And if it's as long as it's a .near account. It's also a useful way to organize sub-accounts. So you can have, say, like application, .ls.near or a DAO at my project.near, and you can keep going further and further. So like each one of these accounts can have sub-accounts or can create sub-accounts. And the near contract actually is one contract that all the other accounts are a sub-contract or a sub-account from. So all accounts can operate as smart contracts. And that's because all accounts are smart contracts. Every single account on a platform is inherently a smart contract. It just may or may not have code loaded into it, and depending on you as a developer, what you're going to be doing. So yeah, it's pretty awesome. All accounts are shards. All accounts are smart contracts. It's pretty crazy stuff. But what I really like about our platform, and I think it really is unique, are access keys. We have 2 types of access keys. Ones that people are more familiar with, which is called full access keys. Standard public private key gives you full control over the account. Send funds, do whatever you want, call contracts, create accounts, add and remove keys, etc. The other style that we have are called limited access keys. And these keys, they can only sign contracts calling a specific contract, or you can make it multiple contracts. You basically can like kind of scope your key and give it permissions based on what you want that key to do. And it cannot manage funds, it can't create sub-accounts, and it can't delete accounts. So it's very limited in what it can do, but it is meant to be shared. And people might think keys are meant to be shared. This is a little scary for me. But yeah, you can create a key, share them with applications, and then have them sign transactions for you on your behalf. This is a funny meme I saw a while ago. Yeah, basically this person, every time they want to shoot a player, they have to log in with MetaMask. Okay, signed a transaction, crap. Okay, crap. Now I need to log in again. And yeah, it's a little bit over the top for sure. But with limited access keys, you can create a key, give it to the application or the game that you're playing, and then it will constantly create these transactions behind the scenes and won't have to redirect you to wallet every time. We have a few of these examples where like a near place where you can draw pixels on the actual canvas, and every pixel you draw is a transaction, but you don't have to sit there and deal with this of constantly being redirected. It's just signing these transactions for you. And you can trust that they're not going to be financial transactions. So yeah, limited access keys can only call specific methods on a contract, but you can have contracts do everything an account can. So if you wanted to give someone an access key that calls a method on a contract, you could actually write in your smart contract a certain method that could do, something a full access to an account could. So kind of opens up your mind a little bit of like what the potential is and what you can accomplish. So like what if you create a method that actually transfers fungible tokens or NFTs? You can easily drop assets to your users. What if you create a method that creates new accounts, allow people to easily create their own accounts? So it's kind of just giving you a little bit of idea of like how you can use access keys on our platform. Another area in chain abstraction would be metatransactions. I'm sure a lot of you guys have heard about metatransactions. On our platform, we have a built-in system to wrap transactions and delegate covering their fees. So basically, if like say Anna.near wants to create a transaction and they want to execute it, they would wrap it with this delegate action message. They would sign it off chain and then send it to a relayer. And then the relayer is going to take that, it's going to attach tokens to it and send it to the network on their behalf. But yeah, the network executes it just as it were Anna.near's transaction. So developers can pay for transactions and delegate them for others, so that way their users don't have to worry about, crypto onboarding or anything like that, and just do transactions on their behalf, which is pretty cool. Chain abstraction in chain signatures. Excuse me. This is something I'm really stoked about. It's really interesting. We're having a lot of fun playing around with it, and I'm really excited about the potential that we have with chain signatures. Basically, what chain signatures are is it allows one near account, a single near account, that can pretty much control almost infinite amount of accounts across many chains. And how is that possible? Well, first, you'll have your one account, and then it's going to take that account and it'll derive like a unique address, a unique address for whichever chain that you're trying to send a transaction or transact on. Then you create a payload, whatever the transaction or payload or action that you want to have signed. So you take your account, you get an address, you construct your transaction or payload, then you're going to call what's called an MPC contract, multi-party computation contract. That's not the service itself, it's just the contract that's going to call the service. And then the MPC contract receives this call and it yields. On our platform, smart contracts can hold off, can wait. It's in an asynchronous nature, so it's a little bit different than Ethereum, where the smart contract will spin up, run a routine, spin down, but it doesn't have to sit there and wait for all of the other promise chain to resolve before it spins back down. So you have to deal with some callbacks and stuff. We'll get into that another time, or feel free to ask me about it later. But yeah, the MPC contract will receive a call, wait for a response. Once it has the response from an MPC node, the MPC node is sitting there listening for it, captures the request, signs the transaction, and then it returns it. So now it can now be relayed out to whatever network it was. And to kind of go through it a little bit more, you have Anna here on the left-hand side, wants to sign in a transaction on Ethereum. It asks to sign the transaction by calling a function call to this MPC contract right here. And meanwhile, the MPC service is actually listening for an event. And it says, oh, I just see that this event was called. Something was called to MPC contract.near. So what it does is it captures this request, and then there's a decentralized node service that reconstructs. It doesn't actually reconstruct the key at all, but it creates the signature. The key never actually even exists, so it's totally secure. These independent nodes sit there and verify and construct the signature and return the signature to the contract, takes that contract and it returns it back to the user. And then after that user has now this signed contract, they can relay it to Bitcoin, Ethereum, Solana, whatever network that you want to transact on. And we'll do a demo of this in just a second. But yeah, chain signatures, you don't need to manage keys across any platforms. You just have one that you log in and use. Basically one near account can nearly infinite amount of Ethereum accounts or any kind of EVM accounts you can control. One near account, almost infinite Bitcoin accounts, and so on and so forth. Solana, Doge, etc. Requests are made on chain. Any account can make requests, even smart contracts. So if you want to write a smart contract that then calls the MPC contract, and do a bunch of cross-chain, cross-contract calls to create something cool, you're able to do that. So moment of truth. Let's do a live demo, see if this will work. And it should, but the live demo guides, you never know how they are going to treat me, and especially with the Wi-Fi. Okay, cool. So this is basically an application in the slides that I shared with you. There's a link to this repo, and in that repo on the upper right-hand side, there's a live website where this is live. So what I'm going to do is I'm going to log in with my wallet. I am going to use Meteor Wallet. I'm going to connect. Cool. Now I'm in. And what it's doing is basically this address here is the address that it's deriving from. The step you're going to have to do here, and we should put in this example, is that you're going to need to fund your initial Ethereum address with some testnet ETH, which is a little bit harder to get these days. But yeah, get some testnet ETH, fund, like once you log in here, you're going to have to fund your Ethereum account. And basically what this account is it's like, it's concatenating your user ID and whatever string you want to put in here. Like I could put Ethereum 3, or I could put Ethereum 2, or I could just put, let's say, ETH 2, whatever you want. It'll create a unique address, or a unique address for the Ethereum network that I can transact with. So right now I have Ethereum 1, which is my first account, and I do have it funded, with 0.09 ETH. Okay, cool. So I'm going to want to send it. Let's send it to another account though that I can actually control. So let's do Ethereum, let's say, because I was already messing around with this online. Let's just do ETH 2. And that'll give me this address, and you can see down here my balance is nothing. So we'll go ahead and I'll copy this address. I'll take, here I'm going to squeeze a little scratch pad over here. I'm going to take this. This will be my ETH 2 address. Cool. So now I can go back to 1. I'm going to grab this Ethereum address. I am going to paste it here, and then I'm going to send 0.001. I should just do 0.1 because again, that testnet ETH is very valuable. 0.001 ETH. Okay, cool. We're going to request a signature. So now what it's doing is it's asking that question over, but before it does that, it's going to ask my wallet, hey, do I approve this transaction? I'm going to say, yep, I'm approving it. And then it's going to go through this chain of events. Right now it's signing the transaction. Now it's sending it over to the multi-party contract. Now the nodes are waiting, hearing for this transaction. Awesome, cool. That's actually quicker than I thought it would be. Returns this transaction. Cool. Now we're ready to relay it. All right. Let's relay this transaction. The transaction has been reverted by the EVM. Oh, man. All right. I'm going to try one more time. The live demo gods. I swear this was working all night last night and all this morning and right before this event. Right before actually I stepped onto this stage, it was working. Oh, man. It always does this. Brought online live and everyone's watching me in the audience sweat up here. Oh my God. All right. Again, it's requesting this transaction. We should also update this front end so that way it not only just relays the transaction, I'm sorry, not relays, it asks me to relay it again rather than trying to do it all over again. Oh, you know what? Actually, let's see if it's the amount of Ethereum that I added, because I feel like maybe I was being stingy with my ETH and it was getting cranky at me. All right, one more time. One more time. I swear this works. We're going to do it one more time. We got just a couple more minutes left. All right, we're going to prove it. Come on. You sign the transaction. At least the service is working where it's signing it. For some reason, the relayer is just unable to relay it. But if it doesn't work this time, we'll keep moving forward, and I swear it will work. And I'll show it to you guys after the cameras are off, and then it'll work. All right, so let's relay. It doesn't work. Okay, I swear this works. I swear it does. And sometimes it doesn't really, it just, that's how it happens. Anyway, I was going to show you multiple. Oh, I know. Wait a minute. Oh, duh. I don't have any ETH there. I did ETH 1. Oh, it's me. User error. Was it PEBCAC? Problem exists between keyboard and chair or something? I think it's me. It's an old IT joke. Oh, I don't think I had money there. I think this is all me. All right. Do we have my address? Okay, we do. All right. Let's just edit all this out on YouTube, please. Let's just pretend we didn't watch this. I know my brother's watching right now. He's like, I want to watch you on YouTube. I'm like, why are you doing that? You're making me nervous. He's watching right now, watching me sweat and fail. It was all my fault. I think the EVM was rejecting it because I didn't have any ETH in that address because I changed the string. Come on. Relay the transaction, please. Oh, it didn't reject me right away. We should have some better error handling. Hey, Bounty, if you wanna get some better error handling on my demo. Oh my God, I think it's gonna work. Yeah, see, and that was all me. Man, they're gonna fire me. Anyway, yay, successful. There, it worked. Cool. So yeah, now we have 0.001 ETH on that Ethereum address. And yeah, we could keep it going. We could take that, you know, and then that was going to be more of the demo, but I don't have time probably now, which would be, now I could take the Ethereum from that account and I could do, all right, let's do Ethereum 5. And yeah, if I did ETH, let's see, 2, I think that's where I sent it to, was it ETH 2? Yeah, cool. There's my balance right there. So yeah, anyway, it's pretty cool. You can just pretty much have an infinite amount of Ethereum addresses and transact using Near, one account to rule them all, kind of, and do a bunch of different things, which I think is pretty dope. All right, let's get back to the presentation, nice and safe over here in the slide land. My coworker did a GIF, and I did not do a GIF. I decided it's Ethereum Global. You guys are all hacking. I'll get up here and do things on the live. So I did it. Let's see. All right, we did access keys. We did this. We did a demo. Cool. Yeah, live demo. All right, it's back to the slideshow. So yeah, chain abstraction ideas. What could you do with this? Well, you could build a smart contract that triggers transactions in any EVM. I could build a DAO like on Near, and then like proposals, or maybe something happens, it could trigger an action on Ethereum. You could buy an asset or change parameters on a contract. You could link cross-chain EVM accounts to an NFT. It could be sold on NFT marketplaces. You could like group them all up. You could have like one account that has access to a bunch of different NFTs and maybe sell that as like a grouping. But yeah, you could build an app that creates link drops, drop assets on other EVM chains. I mean, there's really a lot of really awesome potential here that hasn't really even been tapped into yet. And I'm really excited to see what people like you guys are going to be doing for the hackathon and beyond. Cool. So that's that. We also have another bounty, like I said, with Near and AI. This is going to be yeah, basically what Near's trying to do with AI, like again, we started in 2017 as AI, pivoted for 6 months, been a little bit longer, came back, now doing AI again. What does that mean? And basically like the vision, and it's the same vision as it was with the protocol. It's like we want to enable self-governance. We want to enable self-ownership. You know, you own your data, you own your assets, you own everything. And we're seeing with AI, it's like, okay, I'm sending things to the cloud. Am I owning that? Where are they training that data on? Where is that stuff going? So yeah, it's a little concerning. And basically, yeah, we just want to own our own data. And, you know, we got some alpha that's going to be coming out pretty soon. But yeah, for you guys, not necessarily on what we're building, but we want to hear what you guys like. Take AI and Near and put it together. Build a project where Near is powered by AI, or build a project where AI is powered by Near. Either or. It's pretty much open-ended what you guys can think of. An autonomous agent, contract blockchain, think about smart contracts, make decisions on AI models. How could you combine Near and AI to create a decentralized finance? There's a demo here we can link to. I'm running out of time due to my demo, but again, these slides are available for you. Check out this demo. It's using GPT and a smart contract on our platform. All sorts of ideas that you could have for it. There's a showcase of AI projects being built on Near. Check it out on YouTube, some developer resources, and then next steps for you. Yeah, if you have no idea what you're doing like me, just come and talk to me. We'll figure it out together. Here's all the resources you need. Scan that. It gives you the link tree. It'll give you docs, dev portal, online support. Come see us at the booth. I'm around hanging out. Yeah, that's it. Thank you. Appreciate it. All right. Bye.
Hi everyone, my name is Igor, and today I want to talk about AirDAO. So first of all, big thanks for ETHGlobal to host us. Big thanks to all you guys to come here to learn something new, to try to build something new, to figure out what is globalization, Ethereum, DAOs, crypto, blockchain, all this stuff. So what is AirDAO? Apparently, we was thinking how to build something for real users, because there is a lot of technical complexity right now, but there is not much drivers and not much fuel in normies who are trying to do something with crypto. So we do think that our mission is build the most accessible layer 1 blockchain, focusing on user experience, advanced developers tools, and transparent DAO governance. We do want to empower emerging markets. We aim to bridge financial gaps and unlock new economic opportunities. So we, as ecosystem, we want to be a place where everybody can harness the power of DeFi. Our secure, fast, and affordable network will revolutionize finance for those who need it most, empowering those who make the greatest contribution. The whole idea is to try to look back in what crypto was for all its journey, and there was a place in history when nobody know what the crypto is. When Bitcoin was, everybody was normies. In 2009, 2012, 2014, people doesn't know what crypto is. But in 2015, 2017, a lot of people jumped into crypto, so we was trying to figure out what was the main differentiation, why people was jumping in that times, and why people don't do this, because it's really complex. There is a lot of stuff which is related to technicality, speed, some transparency, but there is not much stuff done with UI UX. So what is AirDAO? We are EVM compatible layer 1 ecosystem with mobile first vision. So all the stuff that you can do with Ethereum is possible on AirDAO. Full support of Solidity, full support of your favorite tools, similar contract addresses, similar address structure. We do have native token Embers and Bonds, 3 other tokens coming soon, which will be related to our DeFi ecosystem. Bond Marketplace is a good place to launch your token DEX, because right now having a blockchain is only one part, another part having a lot of ecosystem stuff as well as tokens. So you need to have stable DEX to be able to handle all this stuff, and definitely liquid staking, because third token is for liquid staking. People want to support network, and while you support network, you need to run a node, and to run a node, you need to do like bare metal server stuff. Apparently, liquid staking is something which is really simplifies support of blockchain for real people. We do have a bunch of partners: DWF, Saprolins, INC4, Modus, Fractal. We do have that vision on focus. We are looking for products which match categories like blockchain, infrastructure, DeFi, real world assets, DAO, AI, GameFi, meme coins. So there is no like really complex product. All products are tailored to be used by normies. We do have a bunch of wallets which support us. MetaMask, because it's like literally Ethereum stuff. Trusty, SafePal, BitJet. We do have a bunch of bridges towards different chains. So we support Ethereum, we support Binance. There is a lot of wrapped version of Embers on both networks, and we do support asset transfer from that network. So if you build in something like cross-chain or account abstraction, there could be a nice place to go. In terms of user acquisition, for user, it's like really easy to buy Embers because we are listed on a bunch of exchanges: Binance, KuCoin, Gate, Max, bunch of other exchanges. So we do want to build something for real people, not for VC and not for like weird guys. So this is the main point of this is accessibility. We do have a lot of tools for builders, especially, as I mentioned, bridge. So if you have contract in one network like Ethereum, Binance, you do some stuff, you can bridge it to AirDAO, spin a bunch of contracts in AirDAO, which will be way cheaper, faster than bridge back. Astra is a DEX, so if you do some token play, you want to be able to put your liquidity somewhere. So basically you can create liquidity pool, trade your tokens back and forth. One day or another, everything goes with a token play way faster than without token. Cosmos is a launch pod or bond marketplace where you can do a nice token sale or user acquisition through our platform. Staking for staking. Apparently, it's hard to mention project which do something in crypto without staking. As well as we have really good mobile wallet with really good infrastructure and tailored for UI UX. Few of our key metrics, we have close to 30,000 network token holders. We past few years we did like close to 100 millions of transactions. Right now we have, it's a little bit outdated, so right now we have even more. So we have approximately 1,000 daily active users past 2 weeks. So it's more like 20,000 monthly active users. And we are still decentralized. So we have more than 170 nodes validated, which kind of like really good. It's hard to find some point of failure when your network is so decentralized. Transaction fee is really low, so you can deploy everything in mainnet directly. There is no reason to build something in testnet. There is no reason to figure out how the faucet works. There is no reason to figure out how to put testnet, where's the testnet explorer. So basically, it's similar to Ethereum in 2018, just build in prod, test in prod, do everything in prod. It's that simple. Apparently, if okay, we're back. If you need some members, just come to our boast. I send you like 10 members, which will be more than enough to deploy wherever you need. For stakers, we do have really good APY because sometimes you are building some protocols, people want to jump in, then it's just like not viable to buy coin for like 5 cents for transaction. So usually people buy from exchange for like 15, 20, 100 bucks. They can use part for your tooling or our protocol usage, and other could be used for staking. Fully EVM compatible, so wherever stuff you will have done on Ethereum should be deployed here like really easy. It gives you a lot of opportunity for code reuse, because I do think that maybe Ethereum is one of the most used network and there is a bunch of code already done there. We did have zero downtime since 2019 April, so we had like really stable network. What is our ambitions? We do have we do want to have a lot of ecosystem dApps. We do want to have 25x on daily active users. We do want to be in top 21 of layer 1 blockchains, and we measured that our network is like easily able to scale to 40 million daily transactions. So we want to have at least 4 million daily transaction in this next year. We are working on impact-based voting, so this is a part of DAO governance. If somebody is willing to build something related to DAO, to governance, to related to soul-bound tokens, let's talk as well. And we do want to have at least 100,000 token holders. This is where our community located. So we do have really big community in Turkey. We do have really big community in France, Germany, Ukraine. We do have really big community in Nigeria, Ghana. We have really great community in Korea, Japan, India, Thailand, Vietnam. So we do really big decentralized community. Our community management team is more like 40 plus members who literally try to talk to normies about crypto. We do have 9 community elected council members, so network is governed by people who have some impact. Literally like community vote who will govern the network in the future. This is our DeFi stack. So it's not possible to build layer 1 on its own. Apparently, developers expect to have way more, and especially users expect to have way more. So layer 1 and wallet is just like really beginning. On top of this, you need to have explorers. We have at least 2. On top of this, you need to have dashboards, you need to have testnets, all this stuff. And apparently it goes further. So we build a full stack of DeFi products for people who are willing to build something on AirDAO, especially with token play. So Cosmos is unique bond marketplace where users can create bonds wherever they like. So if you are familiar with Vested, Cliff, escrow tokens, Cosmos is your place. AstraDex is decentralized EMM, similar to Uniswap V2, a little bit different. You can put any amount tokens against any other amount tokens and apparently become automatic market maker. People can trade back and forth on your liquidity, and you can do, I know, like token distribution through this or some nice mechanics. Harbor is liquid staking, which allows people to stake tokens but still become liquid, so they will have staked version of our tokens. Let's talk again about our advantages. So we do have really high performance and really have good scalability. Network fee is really cheap. We are secure and decentralized. We are fully VM compatible. We have like low block time as 5 seconds. We do have a lot of real active users. So real active users is maybe what we could give to you. And in AirDAO, you can just test in prod. So deploy everything. Don't care about testnet, mainnet. Just come to me. I will give you like few numbers. It will be more than enough to deploy everything. We are focusing right now on decentralized application, basic infrastructure, social fi, GameFi, meme coins, AI, lending protocols, and DEXs. So why do you want to build something on AirDAO? We do like collaborative growth. So on AirDAO, we think that we are growing together, because if your project will succeed, our network will succeed as well. It's fully EVM compatible. Wherever you like on Ethereum should work on AirDAO. Really low transaction fee. We do have some grant and marketing community support. We do have really active community. We do have supported a lot of projects which build something in past, especially like from the hackathon groups. Some weird slides, sorry. This is like what we gathered together. Maybe this is the most interesting slide. So AirDAO is one of the main sponsors in this day. We do have 20,000. There's 1 0 missing total prize pool, but apparently there is like 3 tracks. Best up for AirDAO network, wherever you like, build wherever you like. First prize $5,000, second prize $3,000, third prize $2,000. Anything which could utilize blockchain with some reasons. Second one is attention economy. Attention economy is memes, is social fi, is friend tech, wherever is related to attentions. You can tokenize like, you can do some links with Warpcast, you can create anything which is related to attention. First prize $2,500, second prize $1,500, third prize $1,000. And we do think that people is not the only one who can utilize blockchain. One day or another, AI will have some need to transact. So what is the better way for transacting for AIs and blockchain? Because one of the underutilized tools or possibility in blockchain is cost of creation of your wallet is 0. None of the financial system give you this. You cannot open 100 of bank accounts. You cannot open 100 of PayPal accounts. In blockchain, you can create few thousand of wallets in few seconds, and you can spin few thousand of agents, give every agent $1 and tell them, okay, like do something. So apparently one day or another AI will be able to transact, and we do think that this is an opportunity which should be discovered. So join our revolution. We do want to put normies and put real people in crypto, and we want to make crypto simple for real people. We do have in main Discord of this event, there's like partners track, so we will have support in Discord on ETHGlobal. You can go to AirDAO main site. There will be Telegram channels and there will be Discord channels. There is a special sub channels for builders, which you can join. This QR code literally goes to the builders channel. There should be always somebody on our booth, and there is like a bunch of stuff, a bunch of people who are willing to help you if you will be willing to build something on AirDAO. Thanks. Do we have questions? That's pretty much on my side. Yeah, sure. So the question is what kind of oracles we have. Apparently, we don't have right now any type of oracles, but in case of hackathon, you can mock everything. So it's not a blocker. We are integrating like we are talking like a few oracles providers right now. Past hackathon, people was just mocking oracles and this worked fine. Okay, I wish you good luck and happy building, and I do sure that you'll do a great stuff someday. Thanks, bye.
Welcome today, guys. My name's Matt. I'll be talking a little bit more about Layer 0 and what you can build using the protocol. Before I get started, if you want to follow me on Twitter, my Twitter handle is @uncrackable. And today I'll be going over some of the three main principles about why I think Layer 0 is a unique messaging protocol for blockchain. First, we are a permissionless service, censorship resistant, and immutable. Why does that actually matter? When we talk about cross-chain messaging, bridging is something that comes up fairly often when you want to move assets from chain A to chain B, but do we actually understand what's happening underneath the asset transfer from moving from a wallet to another wallet? At the core, bridge infrastructure is comprised of three different pieces: the messaging service, the function call layer, and then ultimately the application that you build. Diving in a little bit deeper into how this is a reality, when we talk about cross-chain, you can understand that every chain, especially now, is starting to niche down into specific benefits that they offer. Some offer speed, some offer cost savings, some offer more security than others. And when we look at kind of the developer environment today, over the last year, this is the Electric Capital developer report on the screen in front of you, you can see that more and more developers are becoming comfortable with deploying on more than one unique chain. And ultimately, this is needed because of the way that token transfers behave. When we talk about token transfers in today's world, looking at a simple ERC20 smart contract, it's relatively straightforward. A transaction is atomic, where a mapping gets updated from one user's balance and immediately changes the balance of another. But when we talk about cross-chain frameworks, that immediately becomes way more complicated because you have these isolated networks that don't know about each other. And so to update balance, you need to invoke a function on chain A, update the state on that chain, and then somehow relay that that state change is final to the destination network before you can actually receive the funds on the destination. And if you can see from this flow, there's a lot of opportunity for things to go wrong if someone's able to not only manipulate the state change, but the people listening to that state. Ultimately, the way as an industry that we kind of moved around this was with the idea of monolithic bridge security, the idea that there's some entity in the middle listening to events and you are subscribing to them, guaranteeing that, they will provide that security on your behalf. But what happens when that security fails? Ultimately, not just your application, but every application on the destination chain can fall prey to an exploit that falls from verification logic. If a verifier is compromised that's relaying messages from chain A to chain B, everyone is affected. That's kind of why we've seen over the last decade the largest hacks in this entire industry come from bridging-related monolithic security failures. 4 of the 5 largest hacks can amount to nearly $2.5 billion in losses, and the reason for that is fairly simple. You're forcing every application into this fixed channel of security where if that security provider goes down, every application is suddenly at risk. So for us, this is also a really nasty trade-off for the app developer. For the app developer, you're forced to make a decision for your app on whether you pick point A on the network, where every transaction is relatively cheap but insecure, or point B, where every transaction is secure but expensive. Again, the major trade-off here for you is that the switching cost is high. An app is typically immutable on chain, and so if you want to change the underlying security properties, you're looking at changing the core contract, re-auditing, and redeploying your code. That's why I like to say if Ethereum can be thought of as a dark forest, I consider cross-chain a dark ocean. You have multiple islands of isolated connectivity where if a malicious actor gains control of the waterway between them, that island faces an existential threat. And similarly, if your port gets destroyed, you also face an existential threat from the island no longer being able to land ships, or in this case, transactions. Going back to this idea of what is the omni-chain tech stack, at the very core layer of it is this idea of omni-chain messaging, the idea that you can reasonably verify that a message has come from a source blockchain and that that state is final. Layer 0 enables this by allowing you, the application, to actually define what that channel looks like. You can control per destination what type of verification providers are used, the size, scope, and type of verification, and configure that yourself within your tech stack. There's nothing that Layer 0 enforces that you have to use. Everything is customizable. The second piece of this is the function call layer, the idea that once a message is verified, how do we actually deliver that transaction on the destination chain? When you think about it, if we had to have cross-chain messaging where every time I wanted to receive tokens, I had to switch my MetaMask network and then actually make the function call myself, you probably would see a lot less bridging today. The way that we abstract this as Layer 0 is we run a executor as a service, Anyone on layer 0 can permissionlessly execute messages by making the function call themselves, but for a service fee, our executor will automatically swap gas assets and execute subsequent transactions on your behalf, defined obviously by your contract logic. Finally, the last and probably most important piece is the actual application. What do you define as the state change, and why are you initiating that state change to begin with? To make it a little bit easier for developers getting started, we have defined an omnichain app standard that provides a lot of the common utilities you need in an omnichain app at the base layer, and then extend it with two functional contract standards. One, the OFT, Omnichain Fungible Token, which is based on ERC20, and ONFT, the non-fungible token variant. Looking a little bit high level at this transaction workflow, the way that you actually send a message is relatively straightforward. You'll define from your application a message that you want to send, and it'll be encoded as bytes. You'll define a destination chain, and finally this configuration that I mentioned before of who to emit the message to that you want to have verified. From there, this message becomes verified out to each of these independent security modules known as DVNs, or decentralized verifier networks, and emitted to your executor of choice. Once the message has been successfully emitted, each of these DVNs will go and relay the message to the destination chain, which is then enforced by your app's configuration on that destination. It enforces the block confirmations that were waited for on the source chain, the expected DVN threshold and addresses, and makes it relatively straightforward to enforce this threshold on the destination chain. Finally, once it's been verified, anyone can then permissionlessly execute that message through the destination chain, which ultimately triggers the state change in your destination app. This allows you to relay any type of data, any type of assets, any type of data and assets. Moving a bit forward, I'm going to skip through a couple parts here about the configuration stack, just so we have a little bit more time at the end. But this idea of modular security enables you to not only choose between point A and point B, but actually configure every type of application in between using layer 0, meaning that you have a lot more flexibility when it comes to security than you otherwise might. Also, what this means is that as new validation techniques come online, applications can easily switch their security stack over to better and greatest practice, or keep their config immutable depending on their application needs. It's very much tailored around what your app is needing and needing to be serviced at that time. On the execution side, we also enable some separate transaction flows that you can take advantage of in this hackathon. Traditionally, when you execute a message on a blockchain, this is known as vertical composability, the idea that everything in the call stack either succeeds or everything either reverts. And this is definitely useful in blockchains, but can become a little bit difficult when you're working in a cross-chain world, because if, for example, your call to smart contract C fails, the entire transaction reverts, which might not be what the intended logic you want to have is for your application. What Layer 0 offers is this concept of horizontal composability, the idea that instead of having everything either succeed or fail, you can actually define specific checkpoints in the transaction workflow. So, for example, if I wanted to transfer a token in this first call, this would deliver the token on the destination chain and then emit a message via this send compose method. This is emitting an event basically out to the blockchain and telling the executor on the destination to execute a second workflow. And the benefit here is that if, let's say, this token transfer and swap, the swap side of it fails, you can define that the token transfer itself succeeds for the cross-chain message. So it enables you to have a little bit more flexibility when it comes to programming the experience a user has when moving assets to a destination chain, or in the type of state changes that follow your cross-chain message. Beyond just the composability, the executor also enables seamless gas drops to the destination chain. So for a fee, you can deliver, let's say, any native gas token that you want to your destination app in the form of gas limit or message value. Or if you want to relay that gas directly to an end user's address and have that be the only part of the transaction, that is totally valid as well as part of the workflow. So all of these things that I've mentioned in the last kind of 10 minutes or so build up to what I believe are omnichain applications. The idea that any smart contract on any network that Layer 0 supports can send a message permissionlessly without Layer 0 providing a enforced config around security or an enforcement around how much gas you have to deliver. And ultimately what that means is that you as the app get a lot of control over what you can do with layer 0. Anything can be sent via the protocol as bytes, meaning that you can send assets in the form of ERC20 send parameters, you can send NFTs, you can send basically anything that can be codified and stored on a blockchain. And ultimately, that leads to a lot of interesting scenarios that I'll kind of dive into today. I'm going to switch over really quick to my IDE just so you guys have a chance to look through it. So in this repo I have here, there'll be a link to this after in the session, but I have a few example contracts here. I'll make this a little bit easier for everyone to see. The first one that I think is a little bit relevant to the title of this workshop is ABA. ABA you can think of as like a handshake agreement with TCP/IP. The way that it works is you're able to define in your contract itself essentially a return call back to the receiver. So inside Layer 0's contract standard, the OAP, we have two functions, LZ send and LZ receive. I'll start with LZ receive here and kind of define and walk through how this logic works. This function is called anytime a message is received to our destination app from the protocol contract, the endpoint. And what's happening in this call is it basically is decoding from that bytes message a few parameters in particular. The first that I'm storing is just a simple string. So if I wanted to, for whatever reason, send a string from a source chain to a destination, I would encode that data in the send params. I'm defining an arbitrary message type and some gas settings that I want to return to the destination. Now, what this receive call is doing is very simple but very interesting to me. I'm essentially defining a message type called send ABA that if this type is received in the message call, it will return back to the source sender a message. And you can see here we can take advantage of a receive struct called origin, which is part of the message workflow, and basically define this return call back. And so if we dive into a little bit more of the stack traced here, we can do not composer, but ABA, and then crank up the verbosity just a little bit on this test. And you can see here at the bottom, basically what I'm asserting in this test is that on chain B, it receives chain A's message, and on chain B, it receives chain A's message. This setup here for mocking your tests is really, really helpful with Layer 0. We're basically able to, inside our Foundry test here, define a mock chain A and a mock chain B, and then set up an example endpoint with an example app on each of these chains. This is just me encoding the constructor arguments for deploying locally each of these contracts, and then simulate wiring them together using Layer 0's protocol before doing the actual testing itself. In this test, I'm simply just passing this simple string, chain A says hello, verifying the message and delivering it to chain B, and then verifying again the message back to chain A. If this assertion holds true that B's data says chain A's message and A's data says chain B's message, I know the test has worked and I've successfully handshaked the message back from chain A to B back to A again. Overall, this kind of testing framework is really, really verbose because it enables you really quickly to see, one, on EVM compatible blockchains, what my actual messaging framework looks like, and gives you a little bit more flexibility to go through some extra settings. One, which I'll dive into really quick, is called batch sending. This is another message pattern that we have defined in Layer 0's docs. If you're curious about it, basically what we're doing in this call is we are writing a for loop within our send logic to basically ping an array of destination chains all with a single function call. So from one chain, I can send out essentially a web of different calls to various destinations all at once and relay state changes from there. In this test, I'll go through really, really quickly. We're doing something very similar. I'm defining 4 mock chains, 1 sender, and then 3 receivers, and then defining basically in this call, again, 4 different apps on each of these chains, wiring them together. And then in this function test, again, defining these arrays of destinations that I want to send to. And then instead of relaying the state back, I'm actually just updating state on all 3 of these destination networks. And so if we do forge test, match contract again, we'll just pump this in really quick. Believe batch send should work. Great. And then if we crank up verbosity one more time, just so that we can see what's actually happening under the hood, you can see again here, we're basically updating state across all of these networks via this verify packet method to update state on 3 different chains all at once. You can understand that, there might be some latency in between depending on the network and block confirmations that you wait. But this pattern can be really, really useful for if you need to, trigger some type of state change on chain A and then mass update the records on all the other networks that you're connected to. The last one that I'll jump into really, really quickly is just this idea of composing. In the example I provided before, I mentioned this idea of swapping tokens. So the idea that I could send an OFT to a destination chain and mint the ERC20 there and then swap it for another ERC20. This contract composer is relatively straightforward. It's just using safe ERC20, inputting an IRC20 interface, for the contract itself, and then calling and defining this LZ compose method, which basically enforces that the OAP is the OAP we expect, and that the endpoint is the caller. And if it receives tokens via an OFT token transfer, it will look for the amount of tokens that it received, and then just ERC20 safe transfer out an example amount. And I actually have this one already deployed live, so we can take a quick look at this one. I'm going to go into this swap mock contract on Arbitrum Sepolia, hopefully get this up here really quick. And if we go into, perfect, the token transfers here, I'm going to zoom in just a little bit. You can see that for every token transfer in that we do via my OFT, we get one token transfer back out in the form of this LZ compose method. And if we take this transaction hash and we run into layer 0 scan, this is layer 0's block explorer for all of the message pathways. You can see here that this transaction, and actually let me grab the LZ receive that corresponds to it. We can see here in our logs that this transaction was successfully delivered, and this LZ compose correctly swapped those tokens to the receiver that we wanted. So this kind of framework for messaging, the ability to define how your transaction on the destination chain responds to different events across multiple different blockchains, can be really, really useful in case you want to define things like KYC that trigger on different chains, doing some type of private computation and then unlocking something on a different destination, or just piping useful apps that are only available on certain networks. So yeah, hope you guys please build on layer 0. And if you have any questions, we can just jump right in. Thank you guys. Cool. Any questions if we want to jump in? Nope.
I was curious if you could talk more about the DVN. I think I maybe missed.
Yeah, definitely. Jumping back, let me switch over here actually. So let's see if I have this one. Oh, not this deck. So a little bit more about DVNs. Basically, DVNs are just an interface that we've defined on chain for how the protocol receives messages from any messaging provider. So this kind of design here, I'll go actually one step higher that I did previously. This kind of design interface is basically where we define an interface on the source chain for emitting messages out. Whenever you send a message with the protocol, you'll call a assign job method within the protocol stack. This assign job is basically assigning the role to each DVN and paying them a fee for relaying a message. And then what's actually being done from the DVN side is it's routing the packet that has been emitted by the protocol, hashing that packet, and then delivering that hash to the destination chain in this message library. Once that hash is delivered, basically your app defines on-chain configuration in the form of a mapping that says what that configuration threshold has to be. And if that threshold is met, then the message can be executed. But anything can be a DVN. At the moment, I took this slide out. I wish I had it, but I can pull up here. If you go to our docs right now and go to supported security, we have 35 different DVN providers right now. Looking at some of them, the popular ones at the moment, for example, are Polyhedra, which is a ZK-like client using ZK proofs to validate messages on the destination chain. You could combine that with something like Axelar, so using Axelar's middle chain as verification, or you could do something with Layer 0 and Google Cloud, where these are traditional node-based verification platforms, where you're using essentially multiple different signers in an off-chain client that are attesting to messages on the source, similar to an Oracle. Yep. Any other questions or? Nope. Cool. Well, thank you guys so much for coming out. We're going to be doing a $20,000 bounty this weekend, so would love to have you guys hack on us. Thanks so much.